Hi, my name is Zoran. Welcome to the video in which we will complete implementation of the principal part of the .NET Runtime, our own implementation of .NET Runtime. If you ever wondered what happens when your code is compiled and then run, this video will unveil the mystery behind the services that .NET Runtime is providing for us. This video is part of the mini-series. This is the fourth video in the series. So if you get stuck or confused or cannot follow through, then my guess is that that is because you missed one of the previous videos. Please go to the description of this video for the list of all the videos that precede it. Watch them through and you will have the basic knowledge required to watch this video then. If you like what you learned from this video, please subscribe to my channel. Don't forget to tick the bell to receive notifications when new videos are uploaded. Also, what you learn from this mini-series and this video specifically is also part of a much larger video course I published recently at Udemy, Beginning Object-Oriented Programming with C#. It is a 7 hours long course with a whole bunch of code demos explaining the basic principles behind writing C# code, behind running it, how does it get compiled and run so that it really works. Please use the link from the description if you want to enroll to this course, because that will give you a huge discount. And now to code. This is the demo code as we left it in the previous video. It doesn't compile at this point because we are missing some elements in the runtime implementation. So far we have completed implementation of virtual function resolution, so this utility function call is working pretty well. The problem is that it depends on metadata that are stored in the object, but we are not storing it yet. We are not storing it yet because I have not implemented the new operator. That is what is underlined with the red squiggly lines in this code, and that is what we will complete in this video. The runtime requires an ability to load every type. You must have heard of that term, loading the type. So before you instantiate an object of some class, that class must be loaded. It is loaded from the assembly. When your code is compiled into an assembly, assembly also contains a section which describes the types in that assembly. So runtime is effectively materializing those data from the compiled assembly to build metadata about every type it will instantiate. Since I don't have assemblies in this small demo, I will use a coding trick. Okay. Declare an interface with an abstract static method to load a type. So every type in my demo will have to implement this abstract method which loads it. This feature, static abstract methods, is the preview feature in C#. So if you want to write code like this, you'll have to enable preview features in the project file. This was the implementation of base and derived class in our code, and this was the way the compiler sees our classes. It sees them as functions that implicitly receive the this reference, and so my custom class will have to implement this load type so that it works in this version of the runtime I'm implementing. And what will it be to load the type? First, it must resolve the runtime type, so to instantiate the type variable or field in the metadata. And that is how reflection works in .NET. Every object will have a path leading to its own runtime type. And then all those reflection methods and properties will be at your disposal for this object. And they will be specific to the runtime type of every single object you access. And then comes the harder part. building the v-table. That is the critical element without which no object-oriented code can work. And so we will start from the empty v-table and register. Who am I, virtual function? What do I do, virtual function? But not register the getType function because it is not virtual. Alright, that is specific to C#, where we have a distinction between virtual and non-virtual functions. For example, in Java, all the functions are virtual, and all the members, all the member functions of this class would be fitted into the v-table. The same happens in Python, where all the functions are also virtual. But in C#, some functions might be omitted from the v-table. That was intended, I suppose, as the optimization trick when the C# language was first designed. The same thing must be done in the derived type, but there is a distinction. First, it must instantiate the derived type as its runtime type, and so if you got a reference to, say, the base, but actual object is derived, it will point you to a different runtime type object if you try to use reflection. But v-table is more interesting here, because the derived class will start from the v-table of its base and then override its entry. That is how overriding is working in any object-oriented language. C#, Java, C++, Python, all the languages do it this way. And that is how the derived type is adding more virtual functions by just adding an entirely new entry in the v-table, and how it is overriding implementation that it has inherited from the base class by overwriting the entry in the v-table to point to a different delegate. And now we have all the infrastructure in the classes. We have loaded the types, and the ball is in the runtime's yard again, where the runtime must load every type before using it. Of course, it doesn't make sense to load the same type many times over, so the runtime will keep record of loaded types to ensure that every type is only loaded once. There will be a utility here that is either loading the type or getting previously loaded metadata for that type, and then comes the crux of this demo, the element that was missing in the previous video, the new operator. Let me show you how the new operator is implemented in C#. First, it must load the metadata or get the previously loaded ones, because metadata must be set in every instance before custom constructor begins executing. Any arguments you wanted to pass to the constructor will be supplemented with the reference to the metadata that are appropriate for that object or that class which you are instantiating. Finally, the runtime will pass execution to the constructor of your class, but remember, the list of arguments will include the reference to metadata, and that reference will be silently set for you before your actual code begins executing. So if you wanted to call getType in the constructor, for example, that call will be safe because the runtime type will already be set in your instance before your constructor begins executing. What does this code above look like? There is no new operator under the hood. This is syntactic sugar. This is the operator for you. But when compiler sees the call to the new operator, it effectively passes control to the runtime and says, initialize this type, load it, load the metadata, fill in the metadata reference into it, and then step to calling any constructor you find for this list of arguments. No arguments in my demo, but anyway. And the same thing in the next line. And of course, when there is a call to a virtual function. There is no x.whoami, but we must pass control to the runtime again to resolve the function from the instance x, to find the requested method, and only then to invoke the appropriate implementation of that virtual method. If I run the application, you will see that both the types and the virtual functions were resolved correctly. My application is working the same as it would work when the regular .NET Runtime is used. And look, this is the principal implementation of the .NET Runtime. The same thing exists in Java, Python, C++, any object-oriented language. The same principal thing must exist there. Initializing the type metadata before the type is instantiating, setting the metadata in a field in every single object when it is initialized and before its constructor is executed, and then using those metadata to resolve the runtime type if you need reflection, or, more importantly, to resolve actual addresses of virtual functions upon every call made to a virtual method anywhere in the application. And guess what? There's about 100 lines of code here. All that is just what the compiler can see. You don't have access to any of these. This is all infrastructure in C#. But that is what the code looks like when you just declare a base and derived type with a couple of virtual functions, override one of them, make calls to one the other. That is what happens under the hood when you write code like this. So I hope that now you understand the role and services provided by the .NET Runtime to your code and to the compiler. If you liked what you learned in this mini-series, then please subscribe to my video course, Beginning Object-Oriented Programming with C# and learn much more than I could explain in these short videos. Thank you for watching and see you in the next video.